We are going to shift our thinking slightly. We've been dealing with area and perimeter for 2D or flat shapes. Now we are going to expand into the 3D realm. And in the 3D realm, we can no longer talk about perimeter and area because we're dealing in 3D space. We can, however, talk about volume, and we will talk about surface area for spheres. When we talk about volume, we're not talking about how loud the shape is talking to you. We are talking about how much it would take to fill the solid. And it could be anything that we want to fill it up with. You could fill it with sand, you could fill it with water, you could fill it with Valentine's candy. We want to know how much it would take to fill these things up. The first solid that we're going to look at is a prism. And we can't find the volume of these guys until we know what they are. There are 1, 2, 3, 4, 5 different solids we're going to take a look at. And unless you can identify them, you can't go pick the right formula. So we'll talk about some of their properties as well as their formulas. In a prism, you will always have 2 parallel, congruent, bases. That means we're going to have 2 shapes on our prism that are exactly the same size, and they will never touch each other. In this case, our bases are the triangles. That may not always be the case. You could have hexagons, you could have squares, you could have rectangles, but you need to be able to identify the base. The rest of the flat surfaces or faces will always be rectangles. So these are the rectangles, could be squares, that make up the outside, make up kind of the middle of our prism. And then when we talk about the height of a prism, sometimes your prism could be laying down on its side, kind of like the one we're taking a look at. So when we talk about the height of a prism, we're not necessarily talking about the height from the ground up. We are talking about the distance between the bases. So in the case of our happy little triangular prism here, the distance from one base to the other is the height for the prism. That's important. You need to be able to differentiate the height of the prism from the height of any other part of the prism. When we need to calculate the volume of any type of prism, we are going to use V equals capital B times H. Now that's pretty useless unless you know what the capital B stands for. Remember how I told you it was important to be able to identify the base of your prism? B is the area of the base. So if that base was a triangle, then right in there we would use the area of a triangle formula. If the area was if the base was a rectangle, we would use the formula for the area of a rectangle. If it was a dodecagon, it won't be, but if it were, we would use the formula for the area of a dodecagon and substitute that for our B. This little h, again, is the height of the prism. Always, always, always. So let's go look at it. Let's go find a prism that we can play with. Okay. I think this looks like a prism. I'm going to double check and make sure it fits all of my requirements. The first requirement was that it had two congruent parallel bases. So I have this triangle on the bottom. And this triangle, that's not a triangle, on the top. They don't intersect each other. They appear to be the same size. So these are going to be our bases. Now our formula said area of the base times the height. Well, my base was a triangle. So this time, my big B is going to be the formula for the area of my triangle. That's going to be 1/2 base times height, but we're using the base and the height of the triangle. We're not worried about the rest of the prism right now. We're just going to focus on the triangle. I'm going to move this over here. Really? This is just for my triangle. So when I plug in the pieces for my area, the base and the height of a triangle are always perpendicular to each other. Always go and look for the little right angle symbol. That will tell you where the base and the height for your triangle are. This dotted line back here is the base of my triangle. I know it's 5 yards. Excuse me. Now I need the height of my triangle. The height is perpendicular to the base of the triangle. So that's 1.5 yards. I'm going to plug that into Desmos. So 1/2 times 5 times 1.5 gives me 3.75. For the area of my base. I'm going to change that to red so it stands out, and you can see where I'm going to put it. Now, that was all for the triangle. We're going to go back and look at our volume for the prism formula. I know V is capital B. Well, I found capital B. Capital B was 3.75. Remember, this H is the distance between the bases. So that means that H is 4. So I'm ready to go back into Desmos. And I need 3.75 times 4. That means the volume for my triangular prism is 15, and we're measuring in yards, so this is going to be cubic yards, or yards cubed. We will go find another one. I'm going to slide this over just a little bit so they don't run together as much. So if I'm looking for prisms, remember we're looking for 2 flat bases. Here's one. I'm going to identify my pieces. I have what appears to be a square base here. And then I have another one here. So those are my 2 bases. The distance between them is going to be my little h, the height of my prism. So I'm going to start by writing the formula. Volume is area of the base times the height. Well, this time my base is a square. That means area is length times width. So my capital B is going to be the length of my square times the width of my square. So my capital B is 4. I'm going to take that information and go back to my volume formula now. I can substitute the 4 for the capital B. And we already found little h. Little h was the distance between the bases. That was 2. When I multiply, I know 4 times 2 is 8. I don't need Desmos for that part. If you do, please go plug it in. Don't guess and get it wrong because you're embarrassed to go put it in the calculator. If you need the calculator, use it. I need some units on my answer. We're measuring in meters, so this is going to be cubic meters, or meters cubed. So the volume for our square prism is 8 cubic meters. I was looking to see if we had a more interesting prism. Here is another rectangular, another triangular prism. We can go to this one. First thing I'm going to do is identify my bases. So there's one on the top. They are parallel, meaning they do not intersect each other. Even though it sort of appears that they do. Remember, we're talking 3D. So those are my bases. I know the distance between my bases, my little h, is going to be 3 yards. Same formula. I think I'll work down below. I seem to have plenty of room. Big B. Well, my bases are triangles, so my big B needs to be the area of a triangle. That's 1/2 times the base of the triangle times the height of the triangle. I'm going to go zoom in on my triangle a little bit. In my triangle, remember the base and the height for the triangle will always be perpendicular to each other. Here's my little right angle symbol telling me those two lines are perpendicular. That tells me that 6 yards is the base and 2.5 yards is the height of the triangle. So I'm going to plug those two pieces in for the area of the base. Base of my triangle was 6. Height of my triangle was 2.5. I'm going to go back to Desmos, and I need to do 1/2 times the 6 times the 2.5. So I get 7.5. I'm going to make it red. So now, when I go back and pull out my volume formula, instead of that capital B, I'm going to substitute the value that we found. And I know little h. The height of my prism was 3. If I go multiply these together, 7.5 times 3 gives me 22.5. We're measuring in yards, so this is going to be in cubic yards. If you need a little bit more help, feel free to email me. In the next video, we're going to take a look at the next solid.